Today we're going to focus on side angle side, look at some examples with those. The last set of notes I'm going to show you here had a summary for reference of all of the ways to prove triangles congruent, and then we focused on some examples with specifically side, side, side only. So today we'll look at side angle side. So remember, going back, these are all the ways to prove triangles congruent. We've done side, side, side. We're going to get to side angle side today, and then we'll move on to angle side angle and the rest of them. So let's take a look at our new notes today, which have a side, side, side problem at the top, and then we'll get into the side angle side. So let's look at this example here. So remember, my goal is I want to prove that these two triangles are congruent, and I want to do that using side, side, side. So I want to prove that all of the sides are congruent, and once I do that, then I can prove that the triangles are congruent. So let's take a look at what's given and what we need to prove. So you always want to write down what is given first. So in our examples from the last video, we had our statements were already made for us, and we just had to provide the reasons. However, we're taking it up a level, and in this problem, nothing is provided. So we're kind of writing it on our own here, so it's a little bit more challenging. But we generally always follow the same kind of steps. So we always write what's given first. So we're going to write what's given. So the first thing I'm given is that AC is congruent to AD, and that's the first thing. And I know that because it's given. So I'm going to put in what's given for my reasons. And then I'm also just going to go ahead and label that on my image here. So AC is congruent to AD. So that's one pair of sides that I know are congruent. Now, the next thing they give me is that CB is congruent to BD, and that is also given to me. So I already have two things done because they're given to me. So now here at this point, now this is where the thinking comes in a little bit. So I have two of the three sides. This third side here, AB, I want to prove that that's congruent. Now, so I'm kind of trying to think here. I'm not totally sure. So here's what we do. We're going to go back to our reference sheet. That's super important. And look at our options. There's really not that many. Reason sides are congruent. It's given. Okay, so I used those two. Definition of midpoint. Well, I don't really have a midpoint going on in this problem, but then I have this, the reflexive property. The reflexive property says a side is congruent to itself. So let's see if I can apply that in this one. A side is congruent to itself, meaning AB is congruent to itself, right? So it's in both triangles. So it's in this one and it's in this one. So I could then say that AB is congruent to AB because of the reflexive property, and they share that side. So when two triangles share a side, then it's automatically congruent to each other. So AB is congruent to AB, which is that third side that we wanted to prove. And then so I can use the reflexive property. Remember, I'm getting that from my reference sheet. Okay, so when you're doing a problem on your own, you're following the same guidelines. So you're going to look at your reference sheet. What are the reasons that you can use, and how can you prove it? So once I do that, now I've got boom, boom, boom. All three sides are congruent to each other. So now I can say my final thing, which is that triangle ABC is congruent to triangle ABD, and that is by side, side, side. So I proved the triangle is congruent. So that's a pretty quick, easy proof where I just proved those two triangles were congruent using side, side, side. Now I knew to use side, side, side because we're in the side, side, side portion, right? But if it was on a test like your EOC, it wouldn't necessarily say, I mean, it could say use side, 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 but it might not. You have to know that, okay, I see that I can prove these three sides are congruent. They gave me two sides, so I'm going to use the side, side, side theorem. So Now let's look at side angle side. So instead of having all three sides, we are going to have a side, an angle, and a side in that order. So it has to be in that order. So you have examples here. So you have a triangle where you have a side and then you have an angle in between those two sides. And you can prove that those are congruent. Now it has to be in between those two sides. So SAS, not SSA or ASS. It's SAS for this one. So our little theorem here is if AB, so we're looking at our diagram, so if AB is congruent to DE, like in this picture, and then you have the angle, so if you have that side, and then you have the angle in between them, so angle B congruent to angle E, and then you have the other side, side BC congruent to side EF, then we can prove that triangle ABC is congruent to triangle DEF. All right, so that's side angle side. So now we're going to be using that in our proof. So here's a first sample down below. So, and notice it says included means the angle between the sides, which is what I was just saying. And so you have that as a reminder right there. So on a sample proof, so one indication, that it's going to be an SAS proof is you are given this segment and then you're also given an angle. So let's label those on our diagram here. So it says JM is congruent to NL. Okay, so I'm going to label that. And then it gives me an angle JMN. So that's going to be this angle here is congruent to LNM. So LNM, so this angle right here. So you have this side angle. So what do we want to prove is congruent? So remember, the angle has to be in between. So side angle side. Side angle side. So we need this MN segment. We need to prove that it's congruent in both triangles. And you may remember from this previous proof kind of what we're going to use. So notice these two triangles, they're sharing this side. So when they share a side, okay, that means the side is congruent to itself. So we're going to have to use reflexive property to prove that that side is congruent, and that's going to give us our side angle side. So let's go through and label. So JM, we have that. That is given. Angle JMN, congruent to angle LNM, that is given. Okay, so now here's the new one. So now we're saying MN is congruent to MN. So how did we know that? That comes from our reference sheet, and we did this in the previous post. So when we're writing these reasons, this is your Bible for proving triangles congruent. So go back and look whenever you're stuck, okay? Reason sides are congruent. It's given, definition of midpoint, reflexive property. So a side is congruent to itself, so we're going to be using which reason? Reflexive property here. So reflexive property. And then finally, because we have the side angle side, we can say these triangles are congruent, and we can say that is because of SAS. And that's a side angle side proof. So we were able to prove side angle side, side angle side, so they are two congruent triangles. And that's it. So it looks similar to side, 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 but notice we're involving angles here. And so when we do involve angles, we'll be using more of these reasons now, since we're going to be proving that angles are congruent as well in this problem. So let's take a look at the back here and look at some more proofs. So we've got 3 more proofs to work through, and then that's it for the examples for side angle side. So we're going to see all different kinds of diagrams here with triangles, and we're going to try to prove that they're congruent. So for number 5, we have AB is congruent to BC. So we are labeling that. Then we have BD bisects ABC. So remember, when something bisects an angle or a side or anything like that, it creates two congruent parts. So it basically means it cuts it in half. So if we're cutting an angle in half, so if BD right here is bisecting ABC, so we're talking about this whole angle here, and this line is cutting it in half, which intuitively, if you look at that, you can kind of, you can tell that it's cutting it in half. So what that means is that those two little angles are congruent. So congruent and congruent. So those two are equal to each other. So those are two things we're given. So let's go to our statements and our reasons. So AB is congruent to BC. What would we write? Given. Okay, so you can kind of see, although this seems, proofs can be very intimidating at first and just super different than really what you're used to seeing in a math course, but they kind of follow the same sort of pattern when you're working through these simple ones. So given, and then angle ABD is congruent to CBD. So I had marked those as congruent. So how did I even know that those angles are congruent? What would be my reason for that? So I don't know. Let me look at my reference sheet and see what I can say for reasons that angles are congruent, because I said these angles are congruent. So let's see my reasoning here. So I'm going to my reference sheet, reasons angles are congruent. Let's see what I can find. So are they vertical angles, alternate interior, alternate exterior, corresponding? Definition of angle bisector. Okay, so it's a super common one that we'll be using. So we're saying, a bisector will create two congruent angles. So I'm going to be putting definition of angle bisector. And that should remind you of with side, we were doing definition of midpoint. So it's a similar concept. So definition of angle bisector. So that's how I knew that when this cuts it in half, those two are congruent. The definition of angle bisector, that is my reasoning there. Okay, so I'm using that. Now it says BD is congruent to BD. So which property, when we're sharing a side, which property did we say we can use for that one? So BD congruent to BD. That is, if you don't remember, it's in your reference sheet and it's on the previous proof as well, but that is the reflexive property. So you can kind of start to see what we're going to be using over and over in our proofs, the reflexive property. And then, so after all that, look at that. We've got a side, angle, side. So then we can say, once we get that side, angle, side, we have our proof. So these can be pretty long. But we're looking at exclusively short ones. But they can get long, but I think we're going to keep them pretty short for now. And let's take a look at number 6. So look at what we're given here on number 6. It says V is the midpoint of WZ and XY. So WZ and XY. So if V is the midpoint of these two segments here, that means we're going to be cutting those segments in half. So for WZ, when we cut it in half, that means these two are congruent. And then when we cut XY in half, these two are congruent. So we have these two sides now that we know are congruent. Now we need to prove an angle is congruent. If we were doing this on our own, we'd have to, write the statements ourselves, but it does tell us that. So let's go to our proof here. V is the midpoint of WZ and XY. So that's given. That was actually the only thing given to us. And then we had to use our knowledge of midpoint to say that WV is congruent to VZ. How did we know that? That was definition of midpoint. So we're using our definitions. And then angle WVX is congruent to angle YVZ. So how do we know that those two are congruent? So this is going to take you back to, a couple chapters ago, going over congruent angles. And let's go back to my reference sheet and see what I think. How do I know that angles are congruent? So I'm going to go back to my reference sheet, reasons angles are congruent. So basically, what type of angles are these that lets me know that they're congruent? So it's not given vertical angles. So maybe you remember this, maybe you don't, but these are vertical angles. Okay, so that's one of the common reasons that two angles are congruent. So let's look. Remember, vertical angles, they're opposite from each other like this. So we're using that previous knowledge because these are opposite from each other, so across from each other. They're vertical angles. That means they're congruent. So that's how I knew that. So my reasoning here is vertical angles. So I have to use my knowledge of angles. And if I don't remember, I have a list of all my types of angles. If I don't remember what those mean, I would have to look it up in your notes, your previous notes, look it up online, Google it, but you have to know what all these types of angles are. So that's coming back. And then our next statement, which we had written, so XV is congruent to YV, which we had already labeled. How did we know that? Again, that was still from our definition of midpoint. Okay, so we had to use 3 different reasonings there. And so we're starting to apply a little bit more, but then after that we have side, angle, side. So we're able to say that those 2 triangles are congruent. So I'm going to put side, angle, side. All right, and that is another example. So let's take a look at number 7. If at any point you want to try one on your own, you can always pause and give it a try for a second. I'm not going to have you try 7 completely on your own yet because it does introduce something a little bit different with parallel lines that we haven't seen just yet with proofs. So let's take a look at number 7 here. We have this diagram. It says HI is congruent to GJ. Okay, so those 2 are congruent. And then it says something different that we haven't seen. It says HI is parallel to GJ. So that's important to know because remember our angle relationships with parallel lines. We have these alternate interior, alternate exterior, and corresponding angles. So I label, when something's parallel, we label them with the arrow, remember. So this means that these 2 are parallel. So I'm notating that. And then let's go ahead and look at our reasons here. So it's going to kind of guide us through. So HI is congruent to GJ. How did we know that? It was given to us. HI is parallel to GJ. How did we know that? It was given to us. Okay, so now we start with some different things. Now it says GJH. So GJH, this angle here, is congruent to IHJ. Okay, so how would I know that those 2 are congruent to each other? Let's take a look at my reference sheet here. So reasons angles are congruent. So it's going to be that they're one of these types of angles. So basically I need to identify what types of angles are these. So if you recall, and this is why we have the parallel lines. These all must have parallel lines. These are alternate interior angles. So look at them. They're on inside of the parallel line. So if you imagine these extending, and then they're alternate. So they're on the opposite side of this cross line, this transversal. So these are alternate interior angles. So that's why we do need to remember our previous knowledge of angles and parallel lines. That was chapter 2, I believe, where we went over all of that. So you may want to refer back to notes too if you need a little bit of a refresher on those. So that's my alternate interior angle. So what do I have? I've got a side angle. I need this side. So here it is. HJ is congruent to HJ. Which property is that? That is the reflexive property. So same as our previous proofs, reflexive property. So you're starting to see we're using that one a lot. And that's always when they share a side, reflexive property. And then so look at that, we've got side, angle, side. So we can state that the two triangles are congruent. We can prove what we wanted, and we did that by side, angle, side. And those are some side, angle, side proofs.